Okay, guys, so the link that I sent to you guys just before this one was the video that shows you all your basic formulas used to calculate, your basic IV calculations. So things like drops per minute, calculating milliliters per hour, which also in your all's book is known as the infusion rate, or when you're asked how to calculate the infusion pump, that's also known as milliliters per hour. So that was that second formula. The other formula we used to calculate how long an IV will take, so how many hours based on the information that's given to us. And then the last formula shows us how to calculate the total volume. So what we're doing in chapter 6, so in what you're doing on your homework for this week, we are just taking looking at those IV formulas, but looking at them a little bit deeper, and then also looking at some more things that we can do with IVs. So what I'm going to do with you guys tonight, I'm going to go ahead and just walk you all through your homework. Your homework assignment, I think that's kind of the best way to approach it. I mean, yes, it's kind of sort of giving you answers, but at the same time, I mean, the answers are in the back of the book anyway, so at least this kind of guides you on where to begin with your homework, and then kind of helps you as far as what to prepare for next week. Now, looking at your homework assignment, remember we were doing proficiency test 1 on page 239 in your book, and looking at that, that's exactly what it does, is we're looking at taking those basic IV formulas and applying them a little bit deeper. Remember, there were a few things that I told you guys you all could skip. So as we walk through these questions, these 14 questions, there are going to be some things that we skip around in here as well. Starting with part of number 1. Number 1, it tells us that we have 1,000 milliliters of D5NS to run over 150 milliliters per hour. And then it tells us the supply. It tells us that we have a bag of 1,000 milliliters of D5NS. Perfect. So number 1 is asking me how long that IV will run. Now remember, we gave you that formula on the video just before this, that when we're trying to calculate the time, now I'm going to write this down here. When we're trying to calculate the time, we should be told a volume, and remember that volume, I have in parentheses here to show that volume in milliliters, and if we divide it by the flow rate, which we just called F, that was your milliliters per hour, that should be able to tell us how long an IV will take. Well, in number 1, letter A, to do that, it did give us in that problem. It told us that we were to give 1,000 total milliliters at a rate of 150 milliliters per hour. Well, milliliters per hour. So all we need to do is simply just divide those two numbers, and that should give us about how long that would take. When we divide those two, it's going to give us about 6.6. And remember, guys, I told you all last week that you all could give me, or I'm sorry, not last week, but on Monday, I told you all that you all could give me decimals, and that would be fine. 6.6 hours is totally acceptable. For those of you guys who are wanting to convert it to hours and minutes, that translates out to be about 6 hours because of that number that's there in front of the decimal, this one right here. If you're curious and if you want to take your decimal and turn that into minutes, all you have to do is take that 0.6, multiply it by 60, since there are 60 minutes in an hour, and 0.6 times 60 is 36. So this would translate out to be about 6 hours and 36 minutes if you're looking into that. But like I said, 6 hours, or 6.6 hours, I apologize, is totally fine. Okay, so that's what we did for letter A. We were just using that basic time formula. In letter C, we're using our drops per minute formula. Oh, I'm sorry, I skipped over B because I did tell you guys in class, and for those of you guys who weren't there in class, I did tell you guys that you all don't have to pick the tubing. Picking the tubing was kind of tough on me too. I wasn't sure. There's just rules that apply for whether you're using macro drip tubing or micro drip tubing, and that was earlier on in the chapter explaining when we use each one, and I'm not going to require that you guys tell me that. I do, however, want you guys to find the drops per minute for both, just so you can compare what they would be if we used both. So we can skip over letter B as far as which tubing we would use, but let me show you on letter C, when we're calculating those drops per minute, what we do there, again, our drops per minute formula says this, that we'll simply need a volume, again, once again in milliliters. We're going to divide that by our time, but since we're calculating drops per minute, that time needs to be in minutes. So we might have to do some converting here to get those hours into minutes. And then we're going to simply just multiply by our drop factor, and our drop factor is always going to be given to us based on the tubing that's used. And again, in this case, in number 1, we want to calculate both. We want to see what we would do if we had macro drip tubing, which looks like in number 1 is 10, and then micro drip is always 60, and it gives us that in number 1 anyway. So in calculating both of those, if I wanted to see, what it would be for each, again, remember it says that the IV is going to run at 150 milliliters per hour, so our volume there is 150. Now remember, guys, I know that it tells us our total volume is 1,000, but since it didn't give me a time frame for the 1,000 milliliters, instead it gave me a direct time frame telling me that I would receive this IV, or that we're going to give this IV at 150 milliliters per hour. So it tells me the time frame and the volume that I'm going to receive in that time frame. So that's what I'm using is the 150 milliliters per hour. So that's the volume we're going to use here per hour. 1 hour, but remember 1 hour, guys, is the same thing as 60 minutes. So that's what I'm going to use in place of that 1 hour here in this case. And then for macro drip tubing, it says our drop factor is going to be 10. So when we calculate that out, we go ahead and take 150 divided by 60 and then multiply that by 10, and that gives us, what have I done here? 150 divided by 60 and then take that and multiply it by 10. It gives us exactly 25 drops per minute. And then if we do the exact same thing for micro drip tubing, we go ahead and take the same volume divided by the same time, and then I'm going to multiply that by 60, our macro drip tubing. And then that would give us a total of 150 milliliters, 150 drops per minute. So comparing the two, again, I told you guys you all could skip which tubing we would use, but if you're curious, it would be macro drip tubing in this case, because micro drip obviously is going to be a way too big of a number here. 150 drops per minute is way too much to calculate and to count. But like I said, you all are going to skip over letter B. I am not even going to ask you anywhere on next week's quiz to pick any type of tubing, so you don't have to do that at all. All you all had to do on number 1 was letters A and B. So really, looking down to number 2, you're going to do the exact same thing that we just did. So I'm going to go ahead and not do number 2 simply because it's exactly the same as number 1. You all could skip letter A. We skipped letter A because, again, now what is happening here? Oh, there it goes. We skipped letter A because I told you all you all don't have to worry about picking which tubing, so just do letter B, which again we would do the same thing. Just calculate the drops per minute just like we did in number 1. In number 3, I'm going to have you guys skip over both A and B. B is asking us which tubing we would use, but letter A is asking us what we would do to obtain 150 milliliters of normal saline, and we did not cover that at all. For curiosity's sake, what it's saying is since what's only been ordered is 150 milliliters of normal saline, and the supply gave us a bag of 250 milliliters of normal saline. So what it's asking us there is, well, how would we get it down to 150? And the answer would be we would just take 100 milliliters out by letting 100 milliliters of that saline just go ahead and drain out until it reaches 150. So silly, but that's why we didn't cover that. So you all don't need to worry about that at all. So skip over letter A, skip over letter B, but go ahead and go to letter C. And once again, we're going to do the exact same thing that we did in the previous 2 questions. It's asking us what are the drops per minute, once again, for both the macro and the micro. So in that case, you're using the 150 milliliters over a course of 3 hours. So don't forget, you have to first convert that to minutes. Okay, so just walking you guys through that one just to make sure we're all on the same page there. On number 3, it would be again 150 milliliters, and then over the course of 3 hours, but 3 hours converted to minutes, 3 times 60 we know would be 180. So we would use 180 minutes, and then we'd multiply it first by 10 for the, oh, no, I'm sorry, it's not 10 in number 3, is it? I'm sorry, we would multiply it first by 15 for the macro drip tubing in number 3 there, and then the micro tubing, as I mentioned, is always 60. So the second part of that question would be 150 divided by 180, and then multiply it by 60 for the macro drip tubing. Okay, so we'll have 2 different answers once again on letter C. But like I said, you all do not have to pick which tubing you all would choose. Okay, taking a look then at number 4. On number 4, it's simply asking us for milliliters per hour. That's, again, I mentioned earlier that milliliters per hour is the same thing as infusion rate. So on number 4, where it says 500 milliliters of D5W, that's again 5% dextrose water, and it says to solve for 24 hours. An infusion pump is available, so what should you set on the infusion pump? And again, infusion rate is again just milliliters per hour. So we need just that's given to us. 500 milliliters over a rate of 24 hours, you would simply just take 500 milliliters and divide that by our 24 hours. Okay, and that would give you a rate of about 20.8 milliliters per hour. If you round that up to 21, that's okay. For those of you guys who are checking in the back of the book there, it does go ahead and round that to 21, but 20.8 and 21, either way, totally fine. So that's that second formula that we talked about from the first video in calculating those infusion rates, is just looking at milliliters per hour. Okay, so now for number 5. On number 5, just like some of the things we skipped earlier, you guys could skip letter A. Sorry, I didn't mention to you guys today, or not today, but on Monday when I was glancing at your homework, I knew there were going to be some things that you all could skip. I just didn't realize it was going to be this many. But anyway, so you guys can skip letter A. I'm not worried about the amount and type of IV fluid you would use. However, I do want you guys to do letter B. And with letter B, again, you're just calculating the drops per minute. So therefore, you would use, again, 250 milliliters over 1 hour, which we know is 60 minutes. Don't forget to convert it to minutes. And then using macro drip tubing, which in that case, the drop factor would be 10. So then we get down to number 6. With number 6, that was the one where we discussed in class, again, 2 separate questions. So one doesn't have anything to do with the other as far as letters A and B in that one. It's just remembering our knowledge about dosage calculations and then IV calculations. So letter A is incorporating a D over H times Q dosage calculation. So we would remember that again, D over H times Q is our dosage formula. So just writing that D divided by H times Q. Remember, dosage over hand times the quantity. So in letter A, where it says how much aminophylline is needed, well, going back up to the top there, the question itself says aminophylline, we have 500 milligrams in 250 milliliters of D5W to run over 8 hours. What's available is a vial of aminophylline labeled 1 gram in 10 milliliters. So here's what is happening in letter A. What it's asking us is we're trying to give a patient a fluid in an IV. We've got 250 milliliters of 5% dextrose water, which is the solution, which is the diluent that's being used. But we also need to add what's been ordered as far as the medication to their IV bag, which is that aminophylline. And what the doctor ordered in this case was 500 milligrams. Okay, so that's the doctor's order, or in other words, our D. And then our H is how it comes. So you can see what says available is a vial of aminophylline, which is labeled, or phylline, which is labeled as 1 gram per 10 milliliters. So there's our dosage that it comes in. Again, it's 1 gram. Don't forget, we're going to need to do some converting because I want it to match, again, the units there, so we're just going to replace that with 1,000 milligrams. And again, in the question, it was 1 gram per 10 milliliters. So that's our D over H times Q. So when we take that 500 divided by 1,000, that'll give us 0.5 times 10, tells us that we need to add 5 milliliters of that liquid medication. That's what it's telling us. In this case, aminophylline, we've ordered a certain quantity of, or what's been ordered is a certain dosage of a solid form of that medication. But since that medication comes in liquid form, we need to see how much of it needs to be added as a liquid. So letter A would be 5 milliliters of that aminophylline. Then letter B, again, like I said, letter B in these questions, these are completely separate. Letter B doesn't have anything to do with dosage calculations. It's just saying, okay, well, now that we know that we have this IV of 250 milliliters to administer to this patient, what's the drip rate going to be? And again, that's the drops per minute. So we calculate that the same way that we've been doing in most of these questions. We take our total volume, which is 250 milliliters, and then we're going to divide it by, since it was 250 milliliters to run over 8 hours. Don't forget we need to first convert that to minutes. So 8 times 60 is what we're going to do for our minutes, and that gives us 480. So that's what we're going to use here, 480 minutes. And then we'll multiply it by the drop factor. It said to use micro drip tubing. If you guys see that in that very last part of that question, number 6, it says micro drip tubing, which we know is 60 as far as the drop factor. So we would take 250 divided by 480 times 60 would give us about 31.25, which in drops, we know that that's about 31 drops per minute. So that's, again, that was some of the ones that I think we got stuck on in class. Again, remember, they're just 2 completely separate questions, but again, we're just utilizing the information that's given to us. Letter A was a dosage calculation, so we needed the dosage order, the dosage on hand, and the quantity. And then we have some other information given to us in that problem for our drip rate, which again is going to be a volume divided by the total amount of time, and then we multiply that by the drop factor. Okay, now on to number 7. With number 7, that was one of the ones where we were trying to calculate the total intake based on the fact that the patient is receiving a primary IV and then is going to have an additional IV now. So on number 7, it says a patient is receiving a primary IV at the rate of 125 milliliters per hour. The doctor has ordered then an additional medication. It says 1 gram in 75 milliliters. 1 gram is just irrelevant. It's just telling us that they're going to receive 75 milliliters of D5W every 6 hours to run over 1 hour for each of those, each of those times. So it says to calculate the 24-hour parental intake. So what that means is if they're receiving a primary IV all day, they're normally just going to receive this primary IV at a rate of 125 milliliters per hour. So 125 milliliters per hour over 24 hours. You would think that if they're receiving this primary IV alone, they're going to receive a total of 3,000 milliliters over the course of this day. However, what's happening is it does mention that instead what we're going to do is we're going to take some of those hours and we're replacing it with this additional medication. And it says that they're going to receive instead 75 milliliters every 6 hours. And you guys know that every 6 hours is going to be 4 separate times. So if we're getting 75 milliliters on 4 separate hours, that's going to be a total of 300 milliliters on those additional times. And also remember that those 4 hours right here has taken away 4 of our hours from our day. So therefore, they're receiving the primary IV only for 20 of the hours of that day. Therefore, it's not going to be a total of 3,000 milliliters from that primary. It's going to be 125 times 20, which ends up being 2,500 milliliters. And then the other part of their intake is from that additional medication, giving them a total of 2,800 total milliliters for their intake. So it's in these types of questions, it's just a combination of making sure we're adding in the total intake that they're going to receive from their primary IV. But then when you incorporate their additional IV, you have to remember that that is taking over what they're receiving in their primary IV. So that's why we had to deduct the 4 milliliters from that one. I'm sorry, 4 milliliters. So we had to deduct the 4 hours from the original primary IV. So that's what we would have done there in number 7. I hope that helps with that one. If you wanted to kind of get another example, I don't know if there's another one like that on your homework assignment. So just to kind of give you another idea, because I know that some people kind of got stopped up on that one or those types of questions in the book. So let's, for instance, if I gave you guys another one, just to give you a different example of this. Okay, so let's say that a patient needs to receive a primary IV all day at a rate of, let's call it 150 milliliters per hour. And again, they're receiving this all day, but then they need an additional IV, let's call it add for additional. Say every 8 hours, we want to give them an IV for an hour, in length, each of those every 8 hours, each of those times we add that in for a rate of an hour. And we need to add in an IV at 50 milliliters per hour, let's say. So again, what this means is their primary IV, we're calculating this again for the 24-hour period, just like we did in number 7. They're receiving this 150 milliliter per hour solution. They're just receiving some fluids all day at a rate of 150 milliliters per hour, which if we were thinking, if they're only receiving that, that would be 150 milliliters each hour over 24 hours would give us that total that they would receive if they were receiving just that all day. It'd be 150 times 24, which is a total of 3,600. However, what's happening is every 8 hours we need to do this instead. We need to use this IV. So again, in those increments, they're not receiving 150 milliliters. They're only receiving 50. So this number is going to be smaller. So what we're doing, every 8 hours, we know again that's going to be 3 separate hours of our day. So we need to deduct 3 hours from that original one because again, that's going to be dedicated to this IV. So instead, that primary IV, we're only going to receive that for 21 hours. So we can replace that in that calculation as 21 instead. And 150 times 21 is only, let me replace this, is only 3,150 milliliters. So that's what they're going to receive from their primary IV. Well, whereas then the additional IV up at the top there, and I'll just write this up here at the top where I have space, they're going to receive 50 milliliters per hour for 3 different hours. So again, that's going to be an additional 150 milliliters. So we simply just add that to our total with the primary IV. So we know from that they're going to receive a total, and I'll write this over here, sorry, I'm running out of space, is 3,300 total milliliters. So just a little bit shorter than or a little bit smaller than what it would have been had we just received that primary IV all day. So that's what's happening in problems like that. We have to just incorporate what's being added to that additional IV in order to get that 24-hour parenteral intake. Looks like at number 8, we're looking for another pump setting. So again, with the pump setting, we know that pump setting is infusion time, or I'm sorry, the same thing as infusion rate, or in other words, milliliters per hour. In that problem, it says that the patient is to receive 1,000 milliliters of D5 half NS to run at to run at 90 milliliters per hour. Well, it's right there. So in that case, letter A, there was really no math involved in that one because pump settings and infusion rates, that is the milliliters per hour. So letter A, the answer is 90. We want to set it as 90 milliliters per hour as it tells us that in the problem. So hopefully that one was easier than any of the others. Whereas then in letter B, it says how long will the IV run? And again, that's from that first video that I sent you guys that, in order to calculate the time, we need the total volume in milliliters, and we're simply going to divide it by our flow rate, which is milliliters per hour, and both of those were given to us here in number 8. So we just took the total 1,000 milliliters and divided that by the rate of 90 milliliters per hour, and that ends up giving us about 11.1. And again, for those of you guys that are trying to calculate that as to hours and minutes, 11.1 is totally fine. But for those of you guys that are curious about that, that would be 11 total hours from that, what's here in front. But then the 0.1 is where we get our minutes. If we just take 0.1 times 60, that comes out to be about 6 minutes. Like I said, for those of you guys who are curious and doing so and trying to figure out what that would be in actual time, since 11.1 doesn't make a whole lot of sense. With number 9, guys, you all could skip the entire question. I am not going to ask you anything about number 9 because it's just a little bit more complex. So don't worry about that one. We're not going to see that at all. I know that if you're curious about it, if you wanted to see if you got the right answer, it does say that the doctor orders 500 milliliters of aminophylline with 0.5 grams in it to infuse at 50 milliliters per hour. So how many milligrams will the patient receive each hour? So that is just trying to take into consideration how much medication is in that IV. And so the tricky part about this too is the dosage of the strength of that medication in the IV is in grams, and it wants to know what we would receive in milligrams. So if you were curious about this, again, don't forget, I'm not going to ask you this question on the test at all, so don't worry about it, because I know we didn't go over this in great detail. But what it's showing us here, that it says that 500 milliliters of this IV already contain 0.5 grams of that aminophylline, that medication. We know 0.5 grams is actually the same thing as 500 milligrams if we want to look at it that way. So what that means is 500 milliliters of this liquid contains 500 milligrams of medication. So therefore, if we wanted to reduce that and make that, make a little bit more sense, therefore there is 1 gram, for every 1 milliliter that contains 1 milligram of medication. All we did was just reduce this 500 to 500 is the same thing as 1 to 1. So therefore, if a patient is going to receive 50 milliliters in an hour, that means they're also just receiving 50 milligrams in that hour. So that's what number 9 would have come out to be. It would have been 50 total milligrams in that hour. So, but that one was kind of complex and kind of, again, different to think about. You have to kind of apply what we know about grams and milligrams, and again, just see what it's telling us there. So it ended up being kind of easier than it sounded, in my opinion, that again, that's what that meant. But I'm not going to, like I said, I'm not going to ask you that question on the test next week. With number 10, another one, again, I told you guys you all would not have to pick, which you all don't have to choose types and amounts of IV fluid we need. So letter A was one that you all could skip. And then letter B, how would you program the infusion pump? Again, we're just trying to figure out what the infusion pump would be milliliters per hour. So really, since that question, a little bit trickier on that one, it said to run over 60 to 90 minutes. I would only give you guys one time. I'm only going to give you guys one time if I'm asking you guys to calculate the milliliters per hour. However, on number 10, what they wanted you guys to do was to see what it would be for 90 minutes and see what it would be for 60 minutes. So if you did both, for the 60-minute infusion time, 75 milliliters over 60 minutes, well, that's the same thing as 75 milliliters per 1 hour. So the infusion pump would be set as 75 milliliters per hour, whereas then 90 minutes is the same thing as an hour and a half. So your infusion pump would be set at 75 milliliters over 1.5 hours. So we would just simply take 75 divided by 1.5, and that would be set to about 50 milliliters per hour then, in that case. So this was the first one here is the 60 per 60 minutes, and this one was for the 90 minutes. So if you were to do, to see those 2 times, but again, on the quiz, I will only give you one, I promise. Let's see. And numbers 11, 12, 13, and 14 were the last thing that we did in class, and that was strength of fluids. That when we're trying to prepare, half strength, quarter strength, 3/4 strength, which is, we know that 1/4 is the same thing as 25%. 1/2 is the same thing as 50%. So it could be asked that way as well. All of these are looking at that. And remember what we did, like in number 11, where it says, prepare 3/4 strength isocal. The total volume should be 150 milliliters. So what that means is part of this liquid medicine, 3/4 of it should be isocal, and the rest of it should be water, the diluent. And so we want it to be mostly isocal in this case. And so what we have to do is figure out, okay, well, if we need 150 milliliters, we want 3/4 of it to be this medicine. We simply just multiply that by 3/4. Easier to put in our calculator as a decimal, so we'll replace that with 0.75. And so if we just take 150 times 0.75 in our calculator, that gives us 112.5. That means that 112.5 milliliters of this medicine, this is going to be the amount of isocal that we add, because that would be 3/4 of that 150 milliliters. And then the rest of it will be water. So all you have to do to figure out the rest of it is just take what our total volume is going to be, subtract the amount that is isocal, and looks like 37.5 milliliters are going to be dedicated to the water. So that's how we would prepare something that is 3/4 strength isocal. And so on these questions, we'll want both. I want to know how much is the medicine and how much is water. Very similar to number 12, doing the exact same thing in number 12, except different medicine and a different strength. I want it to be 1/2 strength of Vivonex, whatever that is. So if the total volume is 500 milliliters, then this one hopefully is easier than it looks. I want half of it to be Vivonex, and I want half of it to be water. So really this one we can just look at and say, well, half of 500 milliliters is 250. So in this one, 250 milliliters is going to be the Vivonex, that particular medication. If I'm, N, not M, Vivonex. And then 250 milliliters. The other half will be water. So that one, may not have needed a lot of math in that one, just have to be able to split that volume in half. Number 13 is using a percent. So with the percentages, like I said, just think of it the same way as, how we took 3/4 in the first problem. We turned it into a decimal, 0.75. Doing the same thing in number 13, take 25% and turn that into a decimal and use that instead. So 25% is the same thing as 0.25. So if we want the total volume on number 13 to be 400 milliliters, then we're going to take 400 milliliters and multiply it by 0.25 to see how much should be dedicated to the osmolite, or how much should be osmolite. And 400 multiplied by 0.25 is going to be 100. We know that that would be 1/4 of 400 milliliters, right? So therefore 100 milliliters are going to be that osmolite, and then the rest, so 400, no, sorry, that's kind of sloppy. 400 minus 100, we know that that's 300, so that would be the amount of water that we use. And then number 14, again, another one where we probably don't have to use a lot of math in that one. It says that we want full strength isocal, and we want the total volume to be 500 milliliters. So full strength means we want all of it to be that medicine. So therefore, no math involved in this one either. The total volume of isocal should be 500 milliliters, and 0 milliliters should we have of the water. So that's how we would see number 14 if we had full strength of something. We didn't have to do any math or multiplying in that one. So I hope that helps. I hope, walking through that homework helps you guys out quite a bit. Your all's test on Monday will look very, very similar to that. But again, everything that I told you guys you all could skip on the homework, you all will not see that on the quiz. I will not ask you those questions that I asked you guys to skip. So do not worry about those at all. If you guys have any questions, you guys know, reach out to me anytime, and I will see you on Monday.